Hello, welcome to this lesson. In this video, we are going to solve an example on the Bernoulli differential equation. So I have this Bernoulli differential equation here on the screen, which is a nonlinear differential equation. So we are going to look at how we can go about this kind of problems. Okay, so now let me write down the question again. We have dy dx minus 1 over x multiplying y equals x y squared. Okay, so if you have a problem like this, okay, what we would like to do is to change it from the nonlinear form to a linear differential equation so that we can solve. So let's look at how you can do this. The first thing you have to do is to multiply through by 1 over y squared so that you can get rid of the y squared on the right hand side. You're going to have times 1 over y squared, then 1 over y squared. Okay, so now let's rewrite this. You're going to have 1 over y squared dy dx, okay, minus 1 over xy, okay, because this y will cancel out the 2 here, then you're going to be left with only y, 1 y there. And then on the right hand side, this will cancel out this. So you're just going to have x there. Okay, so at this point, I will rewrite the equation as 1 over y squared dy dx, okay, minus 1 over x multiplying y to the power minus 1. I don't want to write the whole thing in fraction form. Okay, that's why I wrote it as 1 over x multiplying y to the power minus 1. It will be the same as what I have here. Okay, so this will be equal to x. Okay, so at this point, what you are going to do is that you are going to change the dependent variable from y to v. Okay, and the v is given as y to the power 1 minus what? N. Okay, and in this case, our n is the 2, that is the power of the y. This is our n. Okay, so from here I'm going to have the v to be equal to y to the power 1 minus what, n, which is 2. So this will give us v to be y to the power minus 1. Okay, so from here what we like to do is that we are going to differentiate the v with respect to what, x. Okay, so we have the v to be equal to y to the power minus 1. So I'm going to differentiate this, okay, with respect to what, x. Okay, and when we do this, that is going to be an implicit differentiation. So we are going to have minus 1 multiplying y to the power minus 1 and then minus 1 again. Then bring our dy dx. So when we simplify this value, we are going to have dv dx to be equal to minus y to the power minus 2 dy dx. Okay, so this will be dv dx equals minus 1 over y squared dy dx. I will make the dy dx the subject, and we are going to have dy dx, okay, to be equal to minus y squared dv dx. Okay, so at this point we can do a substitution into the differential equation we have here so that we can have it in terms of v and what, x, not y and then x. So let's look at that. So we're going to have 1 over y squared, and we know dy dx to be minus y squared dv dx. So that will be times, then bring the minus here. We're going to have multiplying y squared dv dx. Okay, and then we're going to have minus 1 over x multiplying y to the power minus 1, which is now v. So I'll put my v here, and this will be equal to x. So now this will cancel out this, and you're going to have minus dv dx, okay, minus 1 over x v equals x. So you see that now our differential equation is in terms of v and x, where v is now the dependent variable. So at this point, I would like to make the coefficient of the dv dx positive 1. Okay, so because of this, I will multiply every term by minus 1, and then that will give us dv dx plus 1 over x v equals minus x. So this is a linear differential equation, and we can solve this using the integrating factor method. Let's look at how you are going to solve this. So to use the integrating factor method, you're going to get our p of x to be equal to 1 over x. Okay, you're going to get the p of x to be equal to 1 over x, and we know that the integrating factor will be e to the power the integral of p of x with respect to what? X. Okay, let's do the integration. We're going to have the integral of 1 over x with respect to what? X, and this will give us ln x. So we're going to have the integrating factor I to be e to the power ln x, and that will give us x. So at this point, we're going to multiply through the differential equation by the integrating factor that we got. Okay, we're going to use this one rather. So we're going to have x dv dx plus x multiplying 1 over x v equals minus x squared. Okay, so when you do this, that this x will cancel out this, and you're going to have x dv dx plus v equals minus x squared. So at this point, you look at the left hand side and you see that what you have there is product rule. We are going to write it in a compact form, and that will give us the derivative of x multiplying v, okay, with respect to what? X, and then that would be equal to minus x squared. So at this point, we are going to integrate this, okay, with respect to what? X. So you're going to have the integral of the derivative of xv with respect to x dx here, and this will be equal to the integral of minus x squared dx. Okay, so now let's do this integral and see what we are going to get. Okay, so when I do the integral, you see that on the left hand side, the integral will cancel the derivatives. So you are going to have xv, and then this will be equal to minus s cubed over 3. Now bring the constant of integration c. Okay, so at this point, what I'll do is that I would like to make v the subject. So I will multiply through by 1 over x. Okay, so I'm going to have 1 over x here, and then 1 over x here. So this x will cancel out this, and we are going to have v to be equal to minus s cubed over 3x plus c over x. Okay, so this x will cancel out one of the x here. We are going to be left with 2 there. We are going to have v to be equal to minus x squared over 3 plus c over x. Okay, and if you recall earlier on we said that v is equal to y to the power minus 1, which is the same as 1 over y. So we're going to do that substitution in there so that our answer will be in terms of y and x, not v and x. But then we are going to have, instead of v being here, we are going to put this rather there. So we're going to have 1 over y equals minus x squared over 3 plus c over x.